All right, so this time around, I'm going to show you how to build this reference architecture. You've seen this in the common design patterns. It's a 3-node Windows Server failover cluster with a 2-node failover clustered instance and another standalone instance as a replica in the AG. The standalone instance is on a DR data center, so you're combining HA, local HA with DR. This is not something that I highly recommend or even recommend lightly, because for one, managing a failover clustered instance in and of itself is already complex, right? Refer back to the lessons that I've covered in week 1 where we talked about the cluster resource dependencies, where a resource can only start if the other resources that it depends on has already been started. So in the case of the failover clustered instance, it's dependent on the shared storage, it's dependent on the virtual network name, the virtual IP address. So even before you have your SQL Server service up and running, and even before you have your databases online, it has to wait for all of these things. Now, putting your AG on top of an FCI makes it even longer. Longer than when you only have standalone instances. And again, that's because of the implicit dependency. And I say implicit because when you look at the failover cluster manager, you would not see any direct dependency of the AG on the FCI. But by virtue of the AG running on top of a SQL Server instance, and in this case the FCI, there is a direct dependency. You just don't see it the way you've seen it in the cluster dependency report. So this is the one thing that you really have to think about. Don't just do this because. Don't recommend this architecture because, right? Think thoroughly on are there enough people on your team to manage an FCI? Are there competent people on your team to manage a stretched cluster, right? And are there people out there who can manage an availability group running on a stretched cluster that spans across multiple data centers? That kind of thing that we're, the complexity that we're dealing with here, right? And what I'm going to do is I'm going to break it down into smaller sections as well, so that you would see some of the moving parts that make the FCI work, and then adding the AG on top of it, right? This is actually a continuation of the lessons that we've covered in week 2 in the planning and installation, where you're building a stretched cluster, right? Unfortunately, though, what I've seen out in the field is when people start building stretched clusters, they just build the cluster with the nodes from all the different data centers in one shot, and then they encounter a lot of these issues, not realizing the way to do it is build the cluster first with the nodes in the same data center, and then just add the nodes in the other data centers once you're done with it. And that's exactly what I'm going to show you, right? Plus, of course, I need some reference architecture to show you some of the configuration and administration lessons in the future sections. All right, so let's jump in on the demo environment. Oh, and by the way, grab your popcorn, grab your pen and paper. This is a long one. Nobody would be able to build an infrastructure like this in 30 minutes. Nobody, right? What I did in this environment is I've already configured the 2-node SQL Server Failover Clustered Instance. It's a fully functional Failover Clustered Instance, and I'm just going to add the node and build the AG on top of it. But again, this is not something that you do in one day. That's why you have to take notes, capture as much as you can from what I'm going to show you, and do it on your own. Build your own environment, try it out. That way you get to understand more of what availability groups are, failover clustering is, what the networking dependencies are. And this is one of those complex environments where you really are forced to learn everything and go back to the basics of how everything works. So let's dive into the environment so that I can show you how you can build this reference architecture. All right, so we're now in my management machine, and what I did was I installed all of my management tools in here. My best practice has been to not install anything on the servers that are not necessary. In fact, I don't even install SQL Server Management Studio on the servers because I don't want people to be logging in directly and doing stuff on the servers unless it's really necessary. That's why I've installed everything that I need in this management machine, including SQL Server Management Studio, Azure Data Studio, and my Windows RSET tools, my remote server administrative tools. And that's also one of the reasons why I can manage my failover cluster from a Windows 10 machine. I can manage Active Directory from here, from DNS. And what I've done is I've already built a 2-node Windows Server failover cluster here. Okay, these nodes are in the same data center. I also have a fully functional SQL Server Failover Clustered Instance in here under the roles section. I'm still going to call them clustered resource groups. And if you notice, there's more resources in here than you've seen when we built an availability group. You have your SQL Server service, but what I was mentioning earlier, the SQL Server service is dependent on a couple of different things. It's dependent on the failover cluster's virtual network name, the virtual IP address. It's dependent on the shared disk resources. So even before your SQL Server instance can come online, it has to wait until all of these things come online before the databases become available. Okay, so this is a fully functional failover cluster. In fact, I already have this up and running with the databases, right? Ready to go. I've also tested failover and failback of the failover clustered instance, so I know it is fully functional, it is working. Also, looking at the networks, I have 3 network adapters here. The other one is mainly for iSCSI storage. I used iSCSI disks for the failover cluster, and that's why you see that extra iSCSI underscore DC1 network. I'm also not going to be using remote desktop to log into those remote machines. Okay, you are going to see me use PowerShell, especially PowerShell remoting a lot with this, because I don't want to be opening up remote desktop, typing my password, and opening management consoles. I would rather use PowerShell remoting and do management remotely if I can. Okay, so I'm going to use PowerShell remoting to log into the server. And in this case, I'm going to provide the failover cluster's cluster name object. Right, and I'm in. Right now, the failover cluster is running off of TDPRD013. And if you look at the IP address assignment for this machine, it's on the 172.16.0 network subnet. Okay, ignore the heartbeat and the iSCSI. We're only concerned about the LAN network adapter in this case, just to demonstrate that we are working with a multi-subnet failover cluster. I'm going to log into the other machine, which is in my DR data center, using PowerShell remoting as well. And yes, I'm on that machine. And if you look at the IP address assignment for this, it's on the 172.25.1 network subnet. So clearly, the failover clustered instance and the nodes in the failover clustered instance are on the 172.16 network subnet. This one is on the 172.25.1 network subnet, and it's on a DR data center somewhere. Okay. And this is also a fully functional SQL Server instance. I don't have any databases in here. We are going to be adding those databases using the availability group and replicate them, right? This is one example of an inconsistent file and path layout, because when you start looking at the properties of the database, or where the databases are located, in the FCI you have the drive, right? Whereas your standalone instance does not have an M drive, but rather only has the C drive. This is actually one of the very first reference architecture that I built way back in 2012, where the client had a failover clustered instance for their local HA and a standalone instance in their DR data center as a secondary replica. Okay, so failover clustered instance is working. We've got that. It's up and running. The databases are healthy. What's the first thing that we need to do? Well, we need to add the node in our DR data center. Okay. And one of the things that we need to check, recall back the lesson on preparing the servers, is we need to validate DNS name resolution. So this could be done easily by using a simple ping test. Okay, so the server in my production data center can resolve the name of the server in my DR data center. And let's do the same thing on the other node, or the other server, because it hasn't been added to the node yet. Here I'm using the cluster name object instead of the host name. I can also use the host name. Right, so name resolution works. Right, name resolution works to and from. So we can now go ahead and add the node to our failover cluster. Now you can do that either by clicking on the add node link under the actions pane, or you can right click the node, or nodes rather, and click on add node. Okay, now here's the thing that you need to really be careful about, especially if your failover clustered instance is already in production. Databases serving client access or client requests, you don't just go ahead and add the node and not pay attention to what's happening, because it will run the failover cluster validation wizard as part of adding the node. Okay, so we're going to add the server, and then when you start looking at this dialog box or the validation warning, it says yes. When I click next, run configuration validation test, make sure when you hit next, right, you pay attention to what comes up in the next dialog box, not this one, but the next one, right? Here it asks you choose between running all tests or selected tests. Now recall the lesson on running failover cluster validation wizard. It will by default run storage tests with this. Well, your other server in the DR data center does not have access to the iSCSI disks, and it's not practical for me to allow my DR server to have access to the iSCSI disks on my production environment. And that's why I will exclude the storage test. I'm going to do that and uncheck the storage test. Also, you don't want the failover cluster validation wizard to take the storage, the shared storage offline just so it could perform the failover cluster validation wizard. Okay, you don't want to take your failover clustered instances and your databases offline while you're doing this. Okay, pay close attention to that. Click next and next. You're familiar with this, it will run, and we'll see what happens afterwards. All right, so the failover cluster validation wizard completes. At this point, we're not building a new failover cluster, so there's no need to grant my domain account a create computer objects permission, although because I've already done so with the previous failover cluster, no need to grant my domain account the create computer objects. Again, I'm just saying you're not going to need it here because this is already built. You're only adding a node to the existing failover cluster. So if you look at the view report, you would see, well, the system configuration is basically just the software update level, so we can ignore that. My servers are not connected to the internet anyway, so go ahead and click Finish. Now, again, pay close attention to this and make sure that you uncheck the Add All Eligible Storage to the cluster. Refer back to the lesson on the bug in the Failover Cluster Validation Wizard, where I highlighted removing that check, the Add All Eligible Storage to the cluster. Okay, click Next, and it just added that that node to the failover cluster. Now, a couple of things that I wanted to point out here is, for one, you now have a stretched cluster. As a Windows or a system admin, you would need to have another virtual IP address on the network subnet where this server is in. That way, when you decide to manage the cluster, you will have the IP address for that particular network subnet. Okay? So I'm going to show that here real quick. If you look at the server name, notice that it only has one virtual IP address. Okay, and the thing is, the wizard does not even tell you, hey, you have a new node in a totally different network subnet, go ahead and add a virtual IP address associated with that. No. So what you're going to do here is you are going to add another virtual IP address. So let's go ahead and add a new IP address, a virtual IP address for this failover cluster in the same network subnet as that DR node. So we'll click on Properties, and in here you would see under the General tab, you would see the IP addresses. Okay, click on Add, and notice that you now have a new drop down, rather a new option here for the 172.25.1 network subnet. So I'm just going to use, in this case, I'm just going to use .18. Then click Apply. Now this is an example of an OR logic dependency, because now you have two virtual IP addresses to resources that the virtual network name resource depend on. Okay. And it says these changes may cause currently connected administrative. I don't really care about this at the moment, because there's no way that I'm going to stop and restart the cluster name object just to test the DR virtual IP address. I'll just wait until another maintenance window before I do that. Okay. Yes. And if you notice, in here, only the 172.16.0.15 IP address is online, while the 172.25.1.18 IP address is offline. Okay, an example of how the OR logic dependency works. So now that we have a new node, and by the way, let's go back to this. We have a new node in our failover cluster. It has a current vote, but the thing here is that I have a witness in the form of the witness disk. Go back to the lesson on Windows Server Failover Clustering Quorum, where now that we have an even number of nodes, the witness disk will not get a vote. Of course, when this was just a two-node Windows Server Failover cluster with a two-node SQL Server Failover Clustered Instance, it made sense to use the witness disk as our quorum configuration. In this case, again, your DR server does not have access to this shared storage. Hence, the witness disk will no longer make sense to this. So let's configure our failover cluster to use a file share witness in this case. So let's go ahead and configure cluster quorum settings. And I will choose the witness as the file share witness and provide the right path. And of course, in this case, all of the nodes in my failover cluster have access to this file share, and therefore I can go ahead and use this. So I just configured my failover cluster to use a new witness type from the witness disk that was configured previously. Okay, so the failover cluster setup is done. We've configured, adding the node to the failover cluster. We've added the virtual IP address to it. We've also changed the witness type to make sure that all of the nodes have access to the file share. Of course, in this case with dynamic witness, that witness does not get to vote at the moment, right? Because you have an even number of nodes, rather votes, and so your nodes will automatically get the vote while the file share doesn't. Okay, so let's go ahead and enable the SQL Server Always On feature. Okay, I'll do this on the machine itself. And in this case, I'm going to use the SQL Server instance name, not the failover cluster's virtual network name. Well, before I run this, I am going to show you what the effect is. Let me see if I could resize the window. I'm going to show you what the effect is of the of this on a failover clustered instance. Well, I'll run this side by side. So that you can see how the cluster resource dependencies work. So I'm on the failover cluster, and I'm going to run this PowerShell command to enable the SQL Server Always On Availability Groups feature. Now, unlike in a standalone instance, when you do it on a failover clustered instance, it automatically does it on all of the failover clustered instance nodes. It's just like logging into every single node in the failover cluster and then enabling that feature. And if you notice, the SQL Server service is now offline, and then it's coming back online. And of course, it didn't bring the SQL Server agent online as part of that. So let's make sure that the SQL Server agent is back online. As well as the CEIP. Most customers disable this. They don't even add this in the SQL Server Cluster Resource Group, but it is what it is. All right, so we are now ready. We've enabled the SQL Server Always On Availability Group feature on the failover clustered instance. Well, we have to do it on the other node as well. All right, so the feature has been enabled on the failover clustered instance in the production data center, and it's now enabled on the SQL Server instance in the DR data center. Let's go ahead and build our AG. Now, here's the thing, though. Well, first I need to refresh this, as well as this. Here's the thing. I won't be able to use the usual options like automatic seeding and the backup copy restore, because the failover clustered instance has a totally different file structure, drive letter, file path, folder structure than the one in our DR data center. That's why I have to manually do a backup copy restore process to initialize the databases. And I've already created the script to do that. And this is this is really nothing fancy. It's just a simple backup copy restore with no recovery. So we're backing up our Northwind, pubs, and app test DB databases with the log backup, and then connecting to the secondary instance in my DR data center, and then restoring those backups. Note the with a move option here, because my database files are on my M drive on my failover clustered instance, and I don't have an M drive on my DR site. Of course, it's going to be a lot easy if you just provision an additional drive, name it M, come up with a file system structure similar to that of the failover clustered instance. But in reality, people, especially customers, when they implement something like this, they don't plan this way ahead. And so they end up with just that, and then they wait until in the future before they recognize that. The ideal case here will be to make sure that the file system structure of your DR node, the replica that's on your DR side, to have the exact same file structure, the exact same drive letter, folder structure, and all of that, so that you don't have to worry about moving the database as part of your restore process. But this is a reality for a ton of customers. So I'm just going to run this. It will do a backup copy restore. The backups are stored on a highly available file share that all of the nodes have access to. And this is done. So now I can go ahead and see that my databases are now restored on my secondary instance. Let's now go ahead and create an availability group. Now I'm going to use the wizard for this because I've already walked you through using T-SQL and all of the different components. I'll just make life easy for you in this case. I'll use the availability group wizard to build the AG for this. Okay, I'm going to name this AG AG stretched. I can't think of a meaningful name for this, but just so I'm aware that this is kind of like a stretched AG across different data centers. I'll still use the database level health detection. I'll add all databases to my AG. And this is what I want you to have a look at. I cannot check the automatic failover checkbox in the wizard. If you could see me, I'm actually clicking and clicking and clicking nonstop. And the reason for that is because you cannot do automatic failover for your AG when you have a failover clustered instance as a replica. Okay, that's that. So we're going to add the replica, the 17, TDDR 17, and which is also kind of interesting because the UI does not really explain in more detail. There's no way that you could actually do automatic failover with just one node. You need two, right? The failover clustered instance needs to agree that they will have to automatically failover, but again, really doesn't make any sense. Because this is on a totally different data center, we will have to configure asynchronous commit rather on the TDDR017 replica. Endpoints, we've already talked about that, and I'm going to save the listener portion afterwards, just like what I did in the previous example. Now, in this case, I can't use the automatic seeding option. I can't use the full database unlog backup option because, again, the file structures, the drive letters, the folder structures are different on both replicas. So I'm only going to be, I can only use join only in this case. Okay. Click next. And if you look at the checks, it skipped a few of those. And because the databases have been restored with the no recovery option on my secondary instance, I can go ahead and build the AG. And that's it. My availability group has been created. The replicas joined to the AG, and that's it. And you can start looking at your databases on your secondary. Yep, now they're synchronizing. Recall the lesson on availability group fundamentals, where if you have an asynchronous secondary replica, the databases will never be, even if I've got nothing going on here, they will never be in synchronized state. They will always be in synchronizing state. So now we have a 3-node failover cluster. We have an AG with 2 replicas. One is running a failover clustered instance, and the other is running a standalone instance. Let's have a look at what happened to our failover cluster router. If I look at the roles, I now see a new role or resource group named AG stretched, which contains our availability group. Now, remember what I mentioned earlier, there is no direct dependency that you could see inside the Failover Cluster Manager that tells you that this AG stretched availability group depends on this resource group. There isn't. But the reality is your availability group still depends on a SQL Server instance. It just so happened that in this case, it's a failover clustered instance that it depends on. And that's why, even though you won't see an explicit dependency between AG stretched and the TDPRD SQL FCI 016 resource group, the dependency exists. All right, so let's go ahead and create the listener name now that we have a fully functioning availability group. Well, I don't want to say fully functioning because we still don't have the listener yet. So let's build the availability group listener name. So I'm going to go ahead and create the listener. Of course, I'm not going to use DHCP, and what I'll do is I'll name it the same. I'll use port 1433. And if you look at the subnet drop-down list, you start to see 4 IP addresses here. And these 4 IP addresses, before I move on to this, these 4 IP addresses are what SQL Server sees that exists in the failover cluster. Why don't we go ahead and go back to the failover cluster manager to look at the network section here. Now you see an additional cluster and network item under networks. And when you look at this, this is the local area network connection for the node in the DR data center. So before we move on to the adding of the listener name, why don't we go ahead and configure this, rename this so that we can identify exactly what it is for, right? And of course, it uses cluster and client. So let's go back to our IP addresses. We now have to provide 2 IP addresses, just like what we did when we were adding that extra IP address for our failover clusters cluster name object. So we are going to provide an IP address for the 172.16 network subnet. And we are going to add another IP address for the 172.25 network subnet. So now we have 2 virtual IP addresses for our listener name. We'll see this later in the Failover Cluster Manager and how these 2 IP addresses appear in the list of resources in our resource group, or in our case, role, as per Failover Cluster Manager. Okay. Oh, my bad. I have to provide a valid range. 1. There we are. Okay. And this is one of those things where you really have to pay close attention to what you're doing as you're typing the IP addresses, making sure that you're not fat fingering numbers. And there we are. We've managed to create our listener name. So let's have a look at the listener name in the Failover Cluster Manager. You now have 2 virtual IP addresses, one for the 172.16.0 network subnet, which is currently online, and the 172.25.1 network subnet, which is offline. Okay, it will only come online when you fail over your AG from the FCI to the standalone instance in your DR data center. Let's have a look at the listener name inside our our SQL Server Management Studio. One thing that you also have to test is the minute that you create the listener name, is you have to test whether it actually works or not. And it does give me a response. It's responding using the 172.16.0 IP address because that's what I'm currently connected to. I mean, this machine that I'm running on is on the production network, the 172.16.0 network. Let's have a look at what happened with Active Directory. And we'll just refresh this, and you would see AG stretched as a virtual computer object in Active Directory. And if we do the exact same thing here, on the DNS server, you see two virtual IP addresses. One on the production data centers network, the 172.16.0 network, and the other on the 172.25.1 network, which is on the DR network. In the configuration section, I'm going to show you how you can manage this without causing issues on your applications, because your client applications might not support a multi-subnet configuration. So in the configuration section, I'm going to show you how to do this. But for now, we can go ahead and connect to the AG using the listener name. And there it is. Okay, so I just walk you through the entire process. Like I said, this is not something that you do in 30 minutes. I just compressed everything and prepared everything in order to show you how it's done. I highly recommend, for your own practice, build this infrastructure or this architecture on your own lab environment, just to get a feel of what the experience is like and what are the nuances that you have to consider. Because we've covered so many different things. We've covered failover clustering, we've covered stretched clusters and networking across stretched clusters, we've covered failover clustered instances, we've covered adding a node from another data center into your existing failover cluster. We've covered building an availability group where your file structures, your file paths, your drive letters are not the same across your replicas. We've created the listener name with multiple virtual IP addresses. There's so many things that we've covered here. So again, watch this video again, go back to it, take as much notes as you possibly can, and build this even in your own lab for practice exercises, because just going through this alone will give you a ton of insights as to how complex availability group is when you start considering complex architectures like this.